LegitTechTutorials, and welcome to Beginning Assembly Language 8086 IBM PC Family, Pentium 4, and we're going to go over a little bit summarizing of what information I put in the last one. So I guess we'll be taking some notes here. So I'm back in Edit in DOSBox, and go ahead and just leave it there, Untitled 1, and we're going to do some notes. So like I said previously, you have the, so let's go over the registries. So you got the AX, which is the accumulator. Then you have BX, and these are registries. And this is the base registry. You have the CX, and this is the count registry. And then DX is the data registry. And then, like I said, you have an A high and A low. That's A high and A low, and then you have the segment registers, and then you have the DS, which is the data segment. Then you have the CS, and that's the code segment. Then you have the SS, and that's the TAC, I believe. TAC segment, TAC, and ES is the extra segment. So the main ones you're worried about are the DS and the CS. And then, like I said, the first part of the boilerplate is you got to move at data to the AX registry. Where's the at sign? Sorry, I don't know where exactly the at sign is. Okay, data, and move AX into that DS. And as you see up there, that is the the data segment here, the DS. And then this is actually what we're going to do. The other one was in the book, and this is the other way I've learned it. Is this is the print string. So move 9H into A high, and that's in the accumulator. And then load LEA is equal to load effective address, which is similar to how we did in the other one where we move the offset message, but this is easier because it's a little easier to understand. And then, for example, in the last one we call it message. So there's your message that you want to output, or you could do, or if you called it MSG, whatever you'd put the identifier as. Let's just say MSG, and then interrupt 21H. So this is calling the 9H function at the A high, which is a display string, and then you load the message into the top of the data segment. You load it into the data. You load it into the data registry here. That's so if you get confused, data registry, and then interrupt 21H. That calls the DOS, and you jump into the DOS, and that is basically what we have there. And also, I wanted to explain one of these things in the test ASM. So let's go ahead. I didn't explain this message here. So this is your identifier here, and this is declare byte. So you have to have that in front of all of your integers. All of your variables. And then here, this whole string is held inside of parentheses here. And then you do the 13. 13 is carriage return. So this basically, so let's say your cursor is here. So as you see here, my cursor's here. Carriage return returns the cursor here. And then a 10 is a line feed, so it pushes the line down. If you don't replace these, if you just have 13, it'll go here and you have another message, it'll just wipe over top of this message. And this S is this dollar sign is basically to stop the stop the memory there. If you don't have the dollar sign, it will dump your memory on screen. It will be really funny but very frustrating. and definitely have the dollar sign there. So that's basically a closing sign saying and put everything in front of the $sign, and at the $sign you're done. So you could also have the $sign in here, but I think this is a lot cleaner doing it out here. You could also put the 13 in front and the 10 in front, and then your message, it all works. Also, I don't think I really went over it. So here is the load. So here you would do load effective address and just push your message in there. It's the same thing. So let's go ahead and change that really quick. We'll say load effective address DX, and we're gonna push the message in there. There you go. And also, like I guess I didn't really go over it too much. That this is a comment. You do a colon, semicolon, and that's comment. I remember I did go over that. All right, so we're gonna go start our new file, new, and we're gonna go into Untitled 2. We're gonna do our second assembly language program, which is going to be adding up two numbers that are lower than 10. They're one digit. So here we go. Let's go ahead and indent. So let's start our boilerplate, and we'll indent everything out at the end. Stack 100H, and let's go ahead and indent this out. Data message DB declare byte, and we're going to do the carriage return and the line feed at the beginning. We're going to prompt the user to enter a number, and then we're going to have the dollar. We're going to just do the $sign inside here. Where's the $sign? There it is. So there's a $sign. So I guess that's pretty clean too. Message 2 declare byte 10 13. And you're going to say the sum is okay, so that's the end of our data segment. And then we're going to go into the code segment. And we're going to call it, we're going to call the proct add it. So that's the, we're just going to call it add procedure. So that's the name of our procedure. And we're going to move, like we say for our boilerplate, we're going to move add data into the AX, and we're going to move the AX into the DS, into the data segment. And then we're going to go and call the print string, and then we're going to load effective address. We're going to push the message into the DX. And then we're going to move A high, and we're going to move 1H to A high. And this is a read character. So this is reading a character. So this is when this is all you need to do a oops, I forgot to do the interrupt 21. So the interrupt 21H goes into the DOS, prints it out to the DOS. So this loads effective, and it's I guess this loads the image in there, and then this displays it on DOS. I guess you could think of it like that. And then we're gonna move 1H into AH, and the 1H is read character, and 2H is print character. So then we're gonna have the interrupt 21H to display it on to pull it from DOS, and then we're gonna have subtract. So this is gonna be sub from A low 0. So this automatically is pushing 1H into A high. And here, the reason why this is a so we're working in ASCII. So basically, what happens is that we're using it inputs an ASCII character when you read a character. So what happens is that they're giving you a number, but I believe 0 in ASCII is like 52. So if they give you 5, then that is 57, right? But you don't want 57. You want 5, right? So you could return it back to add. So you could actually do the math correctly. So what do? You get this number and you subtract it by 0, so you get 57 minus that 0 character, the 0 ASCII value. So that equals 57 minus that 52 or whatever it is. It doesn't really matter. 5. So that's 5. So now you get the actual 5. So that's what this is. That's called stripping the ASCII. So strip the ASCII. And it's ASCII. Stripping the ASCII off. And let's go ahead and get rid of this here. So subtract, strip the ASCII off. And then we're going to move A low into X. So this is storing. We're storing what we inputted, what was read. So we're storing what was read into A low. So now it's saved to A low. So that's why we have A low here. And we stripped it. Okay, A low. And then we have move A high 9H. And you remember that this is read string. I mean this is sorry, print string. So this is print string. And then we have load effective address. And we're gonna load the message. Okay, so move, here we go, move. Okay, so we got that, and then we're going to, okay, so now we're going to do the second number. So we need the second number, so now we're going to do read character. So that's a read character. And we're going to load the effective address, dx msg. Int 21H, and we're going to move that AH, we're going to read the character, interrupt 21H, and then we're going to strip it. We're going to strip the ASCII off, and we're going to move, we're going to call that Y, and we're going to move AL, where it's stored, into Y. And then we're going to do another print string. So now we're going to print load effective address dx msg 2. So we're going to load that second message in, and we're going to tell them what their sum is. We're going to load x into DL. We're going to add y into DLow. So now this is basically add. So these are two stripped. Both of them are stripped. So it's going to be those values. So this is stripped, and it's going to add this stripped y value into that DLow. So it's pushing it into DLow. So it's basically what you're not seeing is that it says x plus y equals. Because they're both in the same location, they're both in DL. So it's DL plus DL. And that's what you get. And then whatever's left is inside DL, is inside DLow. So you do add. And then what we're doing now is we're adding that ASCII back. So when we push it to the DOS, it displays the correct character. So like we did previously, if you have, so if we, in this case, we did do 0 plus 5 equals 5, but if we output 5 ASCII, because we're pushing an ASCII, it will do some sort of random symbol, whatever that symbol is. So we need to do the 5, and then we need to do the plus the ASCII value, and then that will give us the actual 5. Because now it's that 5 plus 52 is 57, and as we saw with 57, that equals 5. That equals 5 ASCII. So that's what we're doing there. And now we got move to H, which is the function for, you guessed it, like I said, print character. So that's print character, and then we got interrupt 21H, and then we're finishing it up. So that was display, and now we're leaving DOS, giving DOS its power back. heading back to DOS, and then we're gonna do add and then end the procedure, and then we're gonna make it go into add. Okay, so now what we're gonna do, file. We're gonna save it as, and we're gonna say add.asm. We're gonna save that. All right. Now, also a cool thing I saw in this book was also how to do it all in one. Actually, I'm not gonna confuse you with that. So go File. We're gonna do File, Exit, and we're not gonna save. No. Okay. Then we're gonna go. We got MASM. Called it add.asm, and we're gonna link it. Oops, I forgot to do the semicolon at the end, so I have to enter through these. Oh, I did one error here. Sorry. Go back here. Go File, Open, and then go back into add.asm. Okay, so you got in data. I missed two parts. So we do need to declare our variables. So x declare byte, and we're gonna put it as 0. Y declare byte question mark. A question mark means basically that it's null. So there is garbage in there. So whatever was left over in the RAM is gonna be inside there. I mean, you could set them both as 0. So let's do that. File, we're gonna save this, and we're gonna go File, Exit. We're gonna go MASM, add.asm. It says reserve word uses a symbol. Okay, let's go back into edit. It's under add procedure. Add here. Oh. Yeah, so you are going to want to do this. So just call it add it. Because add is a reserved symbol, so we can't have add as the name of our procedure. That is why we have a problem. File. Save, File, Exit, MASM, add.asm. 0 errors. We're going to link it. Oops. Okay, we got something going on. Let me check really quick what we got wrong here. Oh, accidentally did. You got to do link add.obj, or just do add. So now let me make sure. Yep, we got it. So now it says enter a number. Now let's do 3, 4, 4, 5, 6, 7. All right, so there we go. Let's go ahead and jump back in there really quick to take a look at what we had. File, open, and we're going to go add.asm. Now, so here we have declare byte, declare byte, declare byte, declare byte. And we have just the name of our variables here, and we initialize those to 0. And then we have the add it, which is the name of our procedure, and we're moving the boilerplate, add data to AX, AX to DS, to data segment. And then we're outputting the message, so display string, outputting the message, interrupt 21, H. That's 21 hex, by the way, but you don't actually need the H. It's just reminding us that we're doing it in hex. And then we're reading in the character, which is 1H, reading character, then 21H. So that's going back into DOS. And you notice that everything that you want to push into DOS has to be in A high. And here we're subtracting A low, 0 from A low. So whatever, we're pushing stuff that we want to use in A high, and then it brings it back in A low. So that way we don't overcross each other. So it's very, very helpful that we return it in A low, so we're not overriding it A high, the message. So here we're saying strip ASCII, and then we're moving the A low into X, so we're storing that into the variable. And then here we're doing it again, asking. So let's go ahead and comment this here. We're asking for second number. And then here we're reading the character, stripping it, saving second number. And here we're doing 9H, displaying message, interrupt 21H. So now we're saying printing the sum is. And here we are adding. So here we are adding X and Y. And here we're printing the character, which is 2H. So interrupt 21H. And this is the end boilerplate. Oops. You don't have to worry about that. And then we're going to do interrupt 21H. So we're printing character of the sum X and Y. So that's what we got. And we're going to be doing a couple other things. We're going to expand on this and maybe do, subtract and things like that, as well as other different types of arithmetic. But this is basic arithmetic. But you see, doing something like this, you could have it all in one line in C, C++, and Java. You have your main, and you say system.out print or printf, and you have that arithmetic inside there. I mean, not necessarily scanning the lines, so you'd have 2 times scanning the lines. So it's a little bit more. But the cool thing is that what we'll learn later is that you could use macros to put these all inside of a macro. That's actually what we might do next. Alright, so yeah, this is a basic program called add.asm. Make sure you go File, Save. Alright, so this has been Steven from LegitTechTutorials. I'd like to thank you for watching my beginning assembly tutorial. And if you like this video, please subscribe for more videos like it in this series and other series. And if you have any questions, email me. The reference book is inside the description, and I will see you in my next video. Thanks for watching, and have a good day.